Okay, lesson 19 is our first introduction into the derivative. Now, I will tell you up front, what we start off focusing on is the definition of the derivative. The definition of the derivative is a little more extensive. Okay, it takes a little bit of work. We've done some practicing with it already, and I've mentioned it, but you've seen it in homework, just not called derivative. But what's going to happen is the definition of the derivative is something that for AP you need to be able to recognize and understand. However, eventually we will have shortcuts of how to do this. Okay, but for right now we have to practice the long way because knowing that is also important for the AP. So, first of all, let's start off with definition of the derivative. Derivative. The derivative of a function at a point is the slope of the tangent line. Slope of the tangent line to the function at that given point. So there is your definition of derivative. Stick that in your head. Know that derivative is slope. Derivative is slope of the tangent line. That will come up quite a bit. Now, definition of the derivative is right here. A normal function is f of x, correct? You will notice what looks like an apostrophe up here, right? And that apostrophe is our notation for derivative. It's read f prime. So this is f prime of x is equal to, so the derivative is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all divided by delta x. We've been doing that in homework, yes? We weren't calling it the derivative, but I've been telling you along the way when I help you with it that this is the reason they've been preparing it for you. I know we don't always like the Saxon book, but a good thing for it is it does kind of lead up. Okay, so be familiar. Other notation for derivatives. So a popular one is f prime of x. Okay, you also will sometimes see y prime. D over dx is the derivative in relation to x. We don't see this one as much, but a capital D subscript x, so definite derivative with respect to x. We do see this one a lot also, derivative of y with respect to x. And then this is another one, we don't see this one very often, but derivative of y with respect to x as well. Okay. So, example 1. They're giving me a function, y equals x squared. If you want, y is the same thing as saying f of x, right? And they're asking me to find dy dx. So they're asking me to find, if you want to think about it this way, f prime of x. They're giving me f of x, asking me to find f prime. How do we know how to find the derivative right now? Using this definition. Okay, so we're going to use this function along with this definition to work to find the derivative. Okay, or in other words, the slope of the tangent line. So, you ready? First of all, I'm going to start, since they're asking me to find dy dx, I'm going to start by saying dy dx equals. It's a limit, yes? Always write limit. Use proper notation. So the limit as delta x approaches 0 of, okay, the fraction. So on top, guys, f of x plus delta x. So that means you use the f function you're given, right? And every place it says x, I'm going to replace it with x plus delta x. So my function is x squared. Replace that x with x plus delta x, and what do I write? X plus delta x, quantity squared. Okay, so it was x squared. We're taking the x and replacing it with x plus delta x. Because it told us to do f of x plus delta x. Sorry, I've got to glare at my angles. I don't know if you guys do or not, but they asked me to find the derivative. The derivative says to use this formula up above. The formula starts off, the limit, it's f of x plus delta x. So I took my function, x became what they told me to make x. X plus delta x. Minus, what's it say to minus? Okay, yeah. We're minusing f of x, so we're minusing the function as is. The original function was x squared. And then it says to put it all over delta x. Okay? Now, the steps are, we have to do some cleaning up here. So it's still the limit as delta x approaches 0 of, what do I need to do on top? FOIL. X times x is x squared. X times delta x, there's an x delta x plus another x delta x, so my outsides and insides are plus 2x delta x. Last, delta x times delta x is plus delta x squared. So that's from squaring it, and then we still have a minus x squared. All over delta x. Now what? Yeah. Do we have some canceling happening? Yeah. And you should. X squared minus x squared is gone. What do you notice about the two terms left on top? Both terms on top have a delta x in common. So common here is to factor out that common factor. Like that's common notation. So if I factor out a delta x, what remains in parentheses? 2x plus delta x. All divided by delta x. Now what can happen? Okay, a delta x on bottom can cancel with a delta x on top as there's a factor of delta x. Is there a factor of delta x? Yeah. So those delta x's can cancel. Officially, what I have remaining is the limit as delta x approaches 0 of 2x plus delta x. What do you do with a limit when you're ready to take the limit? You plug in whatever the limit approaches, right? So this is the limit as delta x approaches 0. So that means wherever I have a delta x, I'm going to put in 0. So now 2x is going to stay 2x plus delta x, which is 0. Well, 2x plus 0 is 2x. All that work to show the derivative of x squared is 2x. Okay? In given a nice, neat equation like this to begin with, yes, your answer will usually be a pretty nice, neat answer. Because this was the limit as delta x approaching 0, you should have no delta x's in your answer because you've subbed 0 in.
So no matter what form they write the definition of the derivative, like if it's the f prime of x or dy over dx, it's always the same thing.
Yes.
There's no other meaning to everyone.
Nope. It's all the same formula. Okay, you ready to try example 2? Jackson's like, well, not that I really have a choice. Okay, so, given f of x equals x squared, find the slope of the line tangent to the graph of f at x equals 4. So what are they asking me to find? Slope of the line tangent. Where else have you heard that today? Yeah, at the very top. What did I say? The derivative is slope of the tangent line. So what are they asking me to find here? The derivative. That is a big calc thing. Okay? You will continually, throughout the year, be asked to find the slope of the derivative, or slope of the tangent line. When they say find the slope of the tangent line, your brain has to instantly go to derivative. Now, how do we find the derivative? Okay. I mean, officially we use the formula, yes. However, what did we just do? Didn't we just do this one? Can we borrow our own information? Yeah. We know from above that I'm going to call it f prime of x is equal to what? 2x. That is because that is from the problem above, right? So if the given function is f of x is x squared, f prime of x equals 2x, we want the derivative at x equals 4. So I heard it. What are we doing? Plug and chug. Put that 4 in. So 4 goes in place of x. This becomes 2 times 4, which is 8. So this is saying the original function was x squared, right? So on a parabola, the derivative, when you're at the x point 4, the derivative is 8. Okay? And that is the slope of the tangent line. Do you need a Band-Aid?
No, I have like a hangnail type thing, and
okay.
like whenever I press my finger up against it, it stings.
Okay.
Makes it really hurt, right?
Well, if you need a Band-Aid, I have that too, so. Okay. Example 2 was easy, right?
Yeah.
I like that one off.
If we'd had to find the derivative, it would have been more complicated. But given the derivative, it's easy to find the value. Okay, example 3. Let y equals 4x. Find the derivative.
Isn't this kind of the same thing? Doesn't it just do 2 times 4, or is this going to be totally different?
Well, this one, y equals 4x, is the given function. It's like this is our f of x.
So this is more like the first example.
It's kind of it's more like the first example where we have to find the slope. Now, take a shortcut here. I mean, we're still going to actually work it out. But what do you know about the line y equals 4x? I just gave myself away. What do you know about the equation y equals 4x? It is a line, right? It is a line with what? A slope of 4. The line y equals 4x has a slope of 4. Well, any derivative we take is going to be equal to that slope. What is that slope? 4. Okay, so this works because it's a line, but we know that our slope is 4. That means, guess what? This derivative is going to be 4. Now, we're going to do the math because we need to practice this formula. Okay, we need to practice. It is essential. So let's prove what I just showed you. So the derivative of y with respect to x. Okay, you guys know that formula? And by the way, this is a formula you'll have to, since I said you need to know it, be familiar with it, you have to have it memorized, okay? The limit as delta x approaches 0 of f of x plus delta x. So that says I take my function, and wherever I see an x, I'm replacing it with x plus delta x. So what do I write? Okay, so my function was
4x plus 4 delta x.
okay. So my equation was 4 times x. So now instead it's going to be 4 times, what am I using in place of x? X plus delta x. Then what's the next part of my formula say? Minus f of x. What is f of x? Just your original function, which is 4x. All over delta x. Okay. I know Jack already distributed. For the rest of us, shall we distribute? My point is, I get it if you went ahead and did that. So we distribute 4x plus 4 delta x minus 4x all over delta x. What happens? Yeah, on top, 4x minus 4x is gone. I now have the limit as delta x approaches 0 of 4 delta x over delta x. What do you know about the delta x over delta x? Those cancel. So now what do I have? The limit as delta x approaches 0 of 4. In order to take this limit, technically you have to plug 0 in. Where am I plugging 0 into? Nowhere. And so there's nothing, when you plug 0 in, nothing happens. And so what does this limit equal? 4. If you have a situation there where there's nothing to plug in or no place to plug it in, it's just equal to whatever you have there. So the limit is 4.
So those x's always cancel then? Or is there special situations where they do?
Like these,
Yeah, in every single...
there'll be something that cancels. Okay? I mean, I can't, exactly say what. But yeah, there'll be something that cancels. Everything that remains should have, anything that doesn't cancel on top should have a delta x in it. So you can cancel out the delta x in the denominator. Okay?
For example, one, if that wasn't x squared, would it derivative just been 1?
What do you mean? If it had just been x?
Yeah, if it would have just been x.
Yes, the derivative of x is 1. I can't remember what lesson it is, but give us a handful of lessons. We'll actually talk about our shortcuts, and you'll like the shortcuts. So, okay. Example 4. Use the definition of the derivative to show that the derivative of the constant function, f of x equals c, is 0. So f of x equals c, that could be any number, right? And what does that look like, f of x equals c? So if f of x equals 4, that's the equation y equals 4. What's that look like? Horizontal line, right? Okay. Horizontal line. We're proving the definition, by definition of derivative, the horizontal line has a slope of 0. Which, don't we already know that? We already know the horizontal line has a slope of 0. This is just the proof. So, definition of derivative. So I'm going to say f prime of x equals, what am I going to write in front of my definition of derivative? Limit as delta x approaches 0, f of x plus delta x. So we're going to use our f of x. Every place I see x, I'm replacing it with x plus delta x. What did I have? C. C represents a number. Do I have any x? No. So f of x plus delta x is c. Minus f of x. What's f of x? C. Divided by delta x. Well, what do we know about c minus c? 0. So officially, the limit as delta x approaches 0, if I take that extra step, is 0 over delta x. But we know that 0 divided by anything is, no? 0. Yeah. So the limit of delta x approaches 0, limit as delta x approaches 0 of 0 is 0. What happens when you put 0 in for delta x? We don't have any delta x, right? And so this just equals 0. Kind of like the one up above us just equaled 4. No, because that x plus delta x replaces x. In this original function right here, there was no x. C is just a number. And so there was no place to use that x plus delta x. So it just stayed the same. It just stayed that number. It would have been the same thing if I would have said, okay, f of x equals 4. Well then, when I do f of x plus delta x, remember, this goes wherever you see an x. If I just have the number 4, there's no x. So there's nothing to put in place of. And c is like a number. Now, it would have been different if this had been 4x. Then yes, now this would be 4 times x plus delta x.
That makes sense.
Does that help a little bit?
Yeah.
No joke there, that bell seriously scared me. Like, where did Arthurian go?
Oh, what if we all just stood up to him?
She just believed it. She just went to 5th hour class.
I would have really been confused today. Just because I'm writing, I'm like, oh, class is over? Usually the bell does not surprise me, though. Usually it doesn't startle me like that. Okay, continuing on. Let's practice another one. Let y equal 1 over x. Find dy dx. This is our challenge of the day. Exactly. You guys see it coming. It's fractions within fractions. I didn't say it was going to be pretty, but we've got to do it. Yeah, no. Okay, so we're being asked to find dy dx. I'm going to start off with the limit as delta x approaches 0 of f of x plus delta x. So that means I use the given function, which my given function is 1 over x. Every place I see x, I'm replacing it with x plus delta x. So this is going to be 1 over x plus delta x.
Wait, oh, okay. I thought you had like 1 to the x and also y.
Okay? It was 1 over x. X gets replaced, x plus delta x. Sorry, I had to squish it in there. I didn't leave myself quite enough room. Minus f of x. What is f of x?
1 over x.
1 over x. All over delta x. Okay. We've got to do something with this. Right now, on top, I have fraction minus a fraction. How can I deal with fraction minus a fraction? Yeah. Let's work to put this in one fraction. So let me start by writing off the limit as delta x approaches 0, yes. I've got my fraction line. And the idea here, what is the common denominator between x plus delta x and x? Okay. Because this x is added to this delta x, it's its own factor. X is another factor. So my common denominator is going to be x times x plus delta x. That's my common denominator of the numerators. So look at this first fraction. 1 over x plus delta x. What part of the common denominator am I missing? I'm missing the x. So what do I do with this fraction right here? Times it by x. What I do to the denominator, you do to the numerator. So on top, what is 1 times x? X. Then we are subtracting my next fraction. This denominator currently has an x. What part of the denominator am I missing? X plus delta x. What I multiply the denominator by, multiply the numerator by. So that means I'm taking my numerator of 1 and multiplying it by x plus delta x. What is 1 times x plus delta x? X plus delta x. Now, what are we doing though? We are subtracting the quantity x plus delta x. So that means I am subtracting x, and I'm going to end up subtracting delta x. Is that okay that I went ahead and did that? Okay. Clean up. What happens? X minus x cancels. Oops, what did I forget to put on the very bottom? I forgot my delta x. I just didn't write it in. So now, the limit as delta x approaches 0. What do we have happening up here? On top of the top, does that make sense? On top of the top? In my numerator, on top of that numerator, there is a negative delta x. The denominator of the numerator, x times x plus delta x. All over delta x. Now, we have a fraction within a fraction. How do you do with a fraction within a fraction? Okay, so think about this. What if I say it's a fraction and delta x? So that means I'm doing a fraction divided by delta x. Yeah, keep, change, flip, multiply by the reciprocal. So, the limit as delta x approaches 0. And what I'm going to do, I'm going to take that first fraction, I'm going to write it, so that's negative delta x over x times x plus delta x. It's divided by delta x. Dividing by delta x is multiplying by 1 over delta x. Good. More cleanup. Delta x's cancel. The limit as delta x approaches 0. Now what do I have? Negative 1 over x times x plus delta x. And I don't know, if you want to, you could go ahead and distribute that. Honestly, unnecessary in my opinion. What point am I at? Yeah. It's the limit as delta x approaches 0, so where I see delta x, we're going to put in 0. So what do I have left? Negative 1 over x times x is still x squared. This delta x is gone, right? Because it's 0, so I just have negative 1 over x squared.
Seems simple enough.
No sarcasm there, I'm sure. And this, guys, work with the fractions. Don't just skip them. What I really need you to start by getting, though, is getting the ones like what we did on the front side. Make sure you can get those definitely. Give a solid effort at the fractions. I get that they're challenging, but give a solid effort there. Have your notes beside you. Okay, that was the last big one. Example 6. Example 6. Find the slope of the tangent line that can be drawn to the graph of f of x equals 1 over x at x equals 2. Plug and chug, plug what into what?
Plug the 2 into the negative 1 over x squared.
Because, what do we need to connect here if you haven't? Slope of the tangent line is derivative, right? Slope of the tangent line, when they say that, they're saying find the derivative at this point. So, my given function is 1 over x. Based on the fact that that was example 5, we know what is the derivative of 1 over x? And that is negative 1 over x squared. We're trying to find the derivative at x equals 2. So you're plugging in 2. Negative 1 over 2 squared becomes negative 1/4. Okay? You can't just... Did I send it your way? The one that was bugging me? Okay. Grab your calculators. Got a new skill on the calculator today. Notice it states in the directions here. Use a graphing calculator to approximate the slope of the graph of f of x equals 1 over x at the point 4, 1/4. Use a graphing calculator to approximate the slope. What are we approximating? The derivative. Okay. Now, they give us a function, yes? F of x equals 1 over x. Officially, we know the derivative from the previous problem, right? However, I want to show you how your calculator can do this. At the point 4, 1/4. Well, realize what's the only point that matters here. The only part that matters is the x value. Okay? Well, it only matters that it's at x equals 4. So, this is math menu. Option 8. Now, are we all using the same calculator? Yours is an 84 though, right? Okay. So we should be good. Last year I had an 83 in calculus, so those work slightly different. Especially when it comes to this. So that's why. Okay, so number 8, yes? What's it say? It says in derivative. Your calculator will take the derivative of a function at a point. So it won't just, you can't just say what's the derivative of x squared, but you can say what's the derivative of x squared at x equals 8. That's what it will do for you. So go to number 8. You have some boxes to fill in. First of all, d over d, it's asking you what variable are you going to take the derivative of. That is always just an x for us because we're always working in x. So it's d dx.
So 100% of the time it's there.
Yes. I've never not had an x there. That's beyond what I do in here. In your parentheses is the function. What function did they give me? 1 over x. So you can do 1 divided by x. You can do your fraction setup. 1 over x. Then there's a bar. And then it says x equals blank. What's my blank? 4. At what x value are we trying to find the derivative? And so we say 4. And then we hit equals, enter, and we get that lovely decimal. A long decimal.
Enter.
Okay. So, let me write out. It was D box, parentheses. I'm trying to write out the pieces you have to fill in. So we had to fill in that it was, whoops, d dx. We had to fill in our function, and we had to fill in it was at x equals 4. And what is this approximately equal to if we go 4 decimal places? There we go. Negative 0.0625. And I'll write it here. This is math menu, option 8. So when you forget when you're doing the homework. Now, so technically, we could have used this back on example 6. Because you just have to know the original function and the value you want the derivative at. We could have also used this on, what was it, example 4 on the front? No, 3. No, 2. One of them. Okay, one more then. And this is one where you guys have to have it at this point in your lives because you don't know enough. Use a graphing calculator to approximate the slope of the graph of f of x equals sine x at the point pi comma 0. Okay? We don't know anything about derivatives and stuff of sine. So, but notice it does say slope, so we are thinking derivative. Okay. They give me a function, and what's the value I need to know? Your x value, so pi. So, give it a try. dx sine x and x equals pi. And everything I just wrote is not visible. And I feel like saying, there you go, Aubrey, since we know she'll be the one watching the video.
Hi, Aubrey.
Hi, Aubrey.
Hello.
I hope you heard them. Okay, did you guys get it? Math, menu 8. Remember the d blank on the bottom is an x. That's my variable. This is my function, so it's a sine x in that parentheses so it doesn't give me an error. And then at what x value? And it was at x equals pi. Guys, be smart. Use your pi button. Don't try and use 3.14. That does change it slightly. And did you guys all get the same answer? So does that mean all of our calculators are already in radians? If your calculator is in degrees, I don't think it works out the same.
Are we allowed to round up?
Okay, so well, if we go 4 decimal places, I mean right here it's negative 0.9999. Is that 6 nines? I think 8333. If we go 4 decimal places, what does that round to? Negative 1. So I will make a note here that your mode must be in radians. And why must it be in radians? Because we are working with a trig function, right? When you have that sign in there, you have to have your calculator in radians. If it was in degrees for some reason, then
Will the answer be close if it's in
I don't think so.
degrees or
Right.
totally
Are we always using radians, or some do you actually do? Like the problem above, would it matter if it was on degrees?
So it matters.
Okay.
It looks weird right now because you can't tell. There's the exact same problem, two totally different answers.
Well, I know that one.
Yeah.
Like it had pi, but like what about the one above?
The one above would not matter because it did not use any trig. I see what you're asking. Yeah. The only reason this one matters is because it was using sine, and sine has to be in radians to work. At least when you put something like pi in. Now, if we put 180 degrees in, then it would need to be in degrees.
So we are able to check our other answers with this form if it has the x.
If you are trying to find the value of a derivative at a certain point, usually the ones that can't check are the ones using the formula where you have to work out and find the derivative first. It can't check that. Okay? Okay.
Charge my calculator all the way. And not amount of time.
How low was your calculator?
It was really close to being dead, but it wasn't fully dead.
The light was